Hey everyone. So we are going to take a look at graphing quadratic absolute value functions now. And really, it's just an easy extension from what we did in our first lesson, okay? You dealt with the hard stuff in the first lesson, and that was the concept, okay? Having to deal with, thinking about what part of the graph was the positive portion of the graph and what part of the graph was the negative portion of the graph. And we talked about, the positive portion was the part that would overlap with the original graph, or the graph that you would have seen inside the absolute value brackets. And then the negative portion would have been the portion of the original that had negative y values. And because they're now inside the absolute value brackets, we would reflect that over the x-axis and they would become positive, okay? So in our first lesson, we dealt with only absolute value of linear functions. And we saw that all absolute value of linear functions made a v, right? With one or two exceptions, and that was if the original linear function was a horizontal line. We didn't quite see that v. We would need to have a diagonal line in order to see that v, okay? All right, so now we're going to turn our attention to quadratics, but it's going to be done really the same way. You're going to think about what did the original quadratic look like? And then you're going to think, okay, whatever negative portion of that quadratic I have, I'm going to reflect that over the x-axis, and I'm going to make that portion positive, okay? It's that simple. You can already tell from the picture, well, I guess I'm hiding the picture right now. Let me hide myself, and you can see my little introductory picture. You can imagine the red is the absolute value graph, okay? So this blue portion here would have been the original, and then what happens is we get essentially a W shape when we take the absolute value of a quadratic, okay? All right, so let me clear that and let me put myself back. Hi, okay, and we shall get going. I just gotta turn on my mouse. There we go. Okay, so today we learned how to sketch the absolute value graph that is associated with a quadratic function. Let's begin by graphing y equals 2x squared minus 4x minus 6 in our calculator. Sketch this below and label your intercepts and vertex. So you're going to want to pause me. You're going to want to throw this in your graphing calculator. You're going to want to find the intercepts and the vertex. And yeah, just for clarification, when I say intercepts, I mean x-intercepts and y-intercepts. Those are always important to us, okay? All right, welcome back. This is the graph you should have gotten. So I have an intercept at -1, 0, and at 3, 0. Then I have a y-intercept at 0, -6, and I had a vertex at 1, -8. Okay, now we're going to use our calculator to graph the absolute value of 2x squared minus 4x minus 6. Okay, now for most of you with your graphing calculators, if you're a Casio, you can actually in Y2, sorry, I'm just trying to put ink on here while I talk to you. You can mostly in Y2, okay, you can actually just go the absolute value of Y1, okay, like that. And it will link to the same guy you typed into Y1, okay. When you do that on a Casio, what you would do, I'm just grabbing my Casio to tell you, when you're typing, you'll notice that as you're typing an equation down at the bottom, your F1 actually just says Y. So you'd press F1 for Y, okay? On a TI, you can do that as well. If you have a new operating system, there is a shortcut, which I can't remember off the top of my head. I wanna say it's alpha F4, and that will take you and let you do Y1, okay? If you don't have a new TI, you can get it by pressing the variable button and then go over to y variable, call it a function, and then you'll see the y1, okay? I'm doing that off the top of my head, so I hope it's right. But yeah, variable, then go over to y variables, and then a function, and then y1, okay? Or you can just type in the absolute value of 2x squared minus 4x minus 6, okay? However you would like to do it. Okay, so here's the picture you should get. Okay, that's now the red graph. Okay, I've superimposed it on my original screen because really what I want to show you is the same thing that happened with the linear guy, right? Everything that was negative, all of this stuff down here where that I'm tracing with my mouse, all of that stuff was negative, it all got reflected. Look, I had 0, -6, now I have 0, +6. I had 1, -8, now I have 1, +8. This was the point 2, -6. This is the point 2, +6. Okay, so everything that was originally negative now becomes reflected and becomes positive because that's what an absolute value bracket does, right? Okay, so complete the following chart based on your sketches. Okay, so I've got the sketch here for our reference. We're going to talk about the original guy first, y equals 2x squared minus 4x minus 6. Then we'll take, that's the blue guy on this picture that my face is hiding. So let me hide my face. And then the red graph would be the absolute value one, which is this one here, y equals the absolute value of 2x squared minus 4x minus 6. Okay, so I have a domain that was real for the blue graph. The range would have been greater than 8. I have x-intercepts at -1 and at 3. And I had a y-intercept at 0, -6. Then the vertex was at 1, 8. So that is all the information for the blue graph, okay? Again, I'll hide myself for a second just so that you can verify that information, verify that that is all correct. Now we're going to do the same thing for the absolute value graph, which is the red graph. My domain is still real. The range now is going to actually be greater than 0. The x-intercepts haven't changed. They're still at -1, 0 and 3, 0. My y-intercept has changed. It's now 0, +6 because I took that -6 and took the absolute value of it, right? As with my vertex, same thing. The point 1, -8 would now become the point 1, +8 because my y values become absolute values. So that is all the information for the red graph, the absolute value of 2x squared minus 4x minus 6. Okay. Now, invariant points are located where? So an invariant point is a point that remains unaltered in a transformation. Okay, so when we perform some sort of a transformation, it's a point that doesn't change. Now, I'm going to hide myself for a second because I want to really make sure you can see this well. There are an infinite amount of invariant points in this graph, and they are all along the overlapping regions. Okay, so the points that I've highlighted there are actually every point is an invariant point. It's a point that remained unaltered. Now, there are 2 invariant points in this particular graph that we would talk the most about, and that is where I'm actually changing from the positive version to the negative version, or the negative version to the positive version, and that would be the x-intercepts right here. Okay, so in our conversation, what we want to talk about is the following. I said invariant points are all located are located all along the overlapping regions. The 2 we will talk most about are the x-intercepts at -1, 0, and 3, 0. Then an absolute value affects what values? It affects all the negative y values. They will become positive. Okay, so all the negative y values become positive. Okay. Awesome. All right, so guess what? You just learned how to draw the graph of an absolute quadratic. Now we just need to do it algebraically, and you already know how to do it algebraically because you already know how to graph quadratics algebraically, right? We want to find the x-intercepts. Usually we have to factor to do that. We want to find the vertex. Either we need to complete the square to do that, or if we've already factored, we could find the average of those 2 factors and get the x in the middle and then plug that into my original equation and get the y value of the vertex, okay? We need to get the y-intercept. Well, in general form, that would be the constant term, right? Or we plug 0 in for x. Okay, so you already know how to do all of that. You're just going to do the same thing here and then take all your negatives and make them positive, and that's going to give you that cute little W shape, okay? I think in the video there, I just did several W's altogether, but that's okay. Okay, so Consider the function f of x equals x squared minus 4x minus 5. What we're going to do is sketch the graph by determining the intercepts and the vertex. We're going to state the domain and range. Then we're going to sketch the absolute value version of that graph. And then we're going to express that as a piecewise function. And again, stating the domain and the range. Okay, so here we go. First thing we're going to do is sketch the graph by determining the intercepts and the vertex. If I want the x-intercepts, I'm going to plug 0 in for f of x, and I'm going to try and factor it. So to do that, I factor that into x minus 5 and x plus 1. Okay, negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. Remember, I can't do that unless it equals 0, because I can't pull this out and solve unless I'm using the zero product principle. Okay, okay. It does equal 0, and so I am using the zero product principle, so I can say that x equals 5 and x equals negative 1. So I know that those are points I can plot. I know that my y-intercept will be at 0, negative 5. Just plugging in 0 for x if I'm unsure of that. Okay, then I know my vertex. Well, I know the x value of my vertex has to be the average of negative 1 and 5. And so the x value of my vertex has to be 2. Now I'll plug 2 into the original equation. So 2 squared minus 4 times 2 minus 5. And that's going to give me f of 2 equals negative 9. So I know I have the vertex at 2, negative 9. Okay, I now have 1, 2, 3, 4, really 5, because I can mirror the y-intercept. That's 5 friendly points to plot. And so that's going to give me a great looking problem. Okay, so go ahead and do that on your grid paper provided. And it should look like this. Okay. Now we're going to talk about the domain and the range. The domain is real. Don't forget arrowheads on yours, because yours is a hand drawing, right? Any hand drawing that you do has to have arrowheads. Any computer generated drawing doesn't have to have arrowheads, okay? Okay, so domain is going to be real. Range is going to be greater than or equal to negative 9. And now we're going to try and graph the absolute value. Well, I know that 2, negative 9 is going to reflect to 2, 9. I know 0, negative 5 will reflect to 0, 5. And then the other guy at 5, which would have been 4, 5, remember or negative 5, sorry. Remember I talked about that mirror imaging thing. So 4, negative 5 would reflect up to 4, positive 5. Where's my mouse here? There we go. Sketch the graph of g of x equaling absolute value of x squared minus 4x minus 5 using the graph of y equals f of x, just like we went through. And so your finished product there should look like this, okay? The green graph. The green graph grows all around, all around. Okay, now express as piecewise function and state the domain and range. Okay, so remember with piecewise function, we start by putting the positive on top, the negative on the bottom, and then we have to say where the positive exists and where the negative exists. So when you look at this green W here, I want you to think, what was the overlapping region? It was the overlapping region that's the positive. Well, the overlapping region is from here that way and from here that way, right? So the overlapping region would be when x is less than or equal to negative 1 and greater than or equal to 5. Okay, so that would be the original positive version. The negative version will be the hump in the middle there, which is from 1 to 5. Okay, so piecewise function would look like this. I have the positive version up top if x is less than or equal to negative 1 and greater than or equal to 5. Okay, and then the negative version, all the signs got switched, and then that's between negative 1 and 5. A reminder, the positive version gets the equal to portion of the inequality, the negative version doesn't. Okay, then we asked for domain and range. So domain will be real and range will be greater than or equal to 0. Okay, greater than or equal to 0, where y is a member of the reals. Okay, awesome. Let's do it again. graph the function y equals absolute value of negative 2x squared plus 12x minus 10 without your calculator and write as piecewise function. So I'm just going to go through all those steps again. We're going to start by getting the x-intercept. So 0 equals negative 2x squared plus 12x minus 10. Reminder, I don't have to use the absolute value brackets for the x-intercept because the x-intercepts are invariant points, so the same on the original as they are on the absolute value, okay? So I can divide everything by negative 2, which is what I've done here. I have written it as 0 equals negative 2x squared plus 12x minus 10, and then divided everything by 2. So that gives me positive x squared, negative 6x, and positive 5. Looking for two numbers that multiply together to give me 5 and add together to give me negative 6. So that would be negative 5 and negative 1. So x equals 1 and x equals 5. Then the y-intercept will be at 0, 10, because it will have to be the absolute value when I plug 0 in here. So when I plug 0 in for x, I would get out the absolute value of negative 10, which would be positive 10. Okay. All right, and then I'm gonna play with the vertex. I know that the x value of my vertex has to be halfway between 1 and 5. So 1 plus 5 is 6, divided by 2 is 3. Then I know that I can plug in 3 into my original equation and get out the new y value. So I have negative 2 times 3 squared plus 12 times 3 minus 10, all inside the absolute value. Okay, so that gives me the absolute value of 8, which is 8. So I know I have the point 3, 8 as a vertex. So again, I've got 1, 2, 3, and then really 4 and 5 points because I can mirror image that y-intercept. Okay, so on the grid provided, I want you to draw all these points in. Knowing that you're going to look like a W, you should be able to then draw a pretty accurate absolute value graph with this. Okay. All right. I assumed you paused me to do that, and it should look like this. Now you got to ask yourself, if I'm going to write this in piecewise function, I have to decide what was the original overlapping region, right? Well, so what would have been the overlapping region to just, sorry, I'm trying to put there. This would have been the original graph without the absolute value. That would have just been the quadratic, right? So what part of this purple graph would overlap with that guy? Well, remember, that was a quadratic that was opening down. So if that was a quadratic that was opening down, this part here is the original. So that's the overlapping region. That's the positive portion. Okay, because remember, the positive portion isn't whether you are opening up or down. The positive portion is what the original was. The original opened down. Okay, lots of kids think, oh, the positive portion has to be the portion that's opening up. No, the positive portion has to be the thing you see inside those absolute value brackets. Inside those absolute value brackets, I see a quadratic that opens down. That is my positive portion. Okay, so the positive portion exists from 1 to 5, and then the negative portion would exist less than 1 and greater than 5. The equal to sign goes with the positive portion. Okay, and so we should be looking at this for a piecewise function. The positive portion is exactly what I see inside those absolute value brackets. It exists from 1 less than or equal to x less than or equal to 5. The negative portion, I have switched all the signs, okay, and then it exists when x is less than 1 and when x is greater than 5, okay? You guys are rocking this. Okay, so quick little summary here. Remember, when you are taking the absolute value of a function, only the y values are affected. The two most important invariant points are the x-intercepts, because that's where we're going to change from the positive to the negative or the negative to the positive. And then the steps for graphing, you want to graph the original function, y equals f of x. That should have been a y, sorry. Label the x-intercepts in the vertex. And then to graph the absolute value, you want to change any negative y values on the graph of f of x to positive y values, and that will give you that W shape, okay? Awesome. So here is your homework for you. give yourself lots of time to go through it and to give yourself the processing time that you need. Check in with me if you have any questions. And then on our next lesson together, we're going to start taking a look at solving equations, which will be like super fun. Can't wait. I'll see you there. Take care, guys.